Hello everyone, welcome to the course on architectural design of integrated circuits. Myself Indranil Hatai, working as an assistant professor in the School of VLSI Technology, IIST Shivpur. So this course is basically structured in such a way so that it will be helpful to the students, UG students who are doing their final year project, as well as the MTech student and that means research scholar who are new into the digital VLSI design. And I will try to also cover up the situation or the problems which are being faced by the students whenever they started or working on this research or their project work. Apart from that, this course will be also helpful to the students who are basically facing any job interview, like that means those who are working on the digital design side, that means the companies like Qualcomm, then Broadcom, then MediaTek, Snapdragon, TI, Intel, any of the digital company where this digital VLSI is very much useful, and you are that means candidate for giving the job interview at those companies. So I will try to cover up the interview type of questions and their solution, that means how to tackle those problems, how to solve those problems, whichever has been asked during the interview. So I will try to cover up that things also in my course. And what will be, that means why this course will be helpful to them, because that means starting point of any VLSI digital design, that is there are 3 points like speed, power, area, okay, and any digital VLSI circuits that starts with the specification, right? So specification that can be that means it is the starting point of any digital VLSI design. So after that it comes with the different algorithm, then that algorithm can be that means implemented, or that algorithm can be mapped into the different architecture, then that architecture has been shifted to the logical level, then that logical level has been shifted to the circuit level, something like this. That means this is the VLSI design flow, okay. So to meet the specification for any product or any system, that means the digital design circuit, you need to pass, or you need to that means go through the different optimization phase, okay. So that's why there are optimization in any of this that means flow, which is whether that is you are working on the algorithmic aspect, or whether you are doing these architectural aspects, or you are working on the logical aspects. So that means optimization, now I can say that optimization can be done in algorithmic side, optimization can be done in architectural side, optimization can be done in the logical side also. And what is the intention for doing that? The main intention is to meet the stringent specification of your system, whatever you are trying to design in company or in academia, anywhere. So in this course we will see that that means how this will be helpful. In this course, what we will do, we will take some of the that means basic elements like that arithmetic function which is being used, or which are the that means basic components for building any digital system, okay. So we will try to optimize those circuit, or we will try to that means see, or we will try to solve those problems or tackle those problems. How can I efficiently that means design a circuit which can meet the stringent specification, okay. So something like this, if I say, that means if I just that means explicitly if I say, that is, suppose I need to design one multiplier, okay. So multiplier can be, or I want to design an adder. So multiplier, adder, divider, any of this arithmetic circuit can be implemented in different way, various way. There are various way for designing it. And why there are various ways? Because some of the adder architecture that may be like they may be faster. So as you know that actually prior to that I just want to say one thing. You need prerequisite, that means before joining to this course, you need a prerequisite knowledge about the digital circuit design or this digital design. Okay. So, whenever I am talking about this optimization, okay, so optimization is very much required to meet the stringent specification. So, what I said that there are various architectures for adders, multipliers, dividers, so many arithmetic operations. Okay. And there are some of the function that follow some of the algorithms. So, those algorithms, how can I map into a efficient architecture, that we will see in this particular course. Okay. And what I was trying to say that there are different, that means architectural, that means blocks, that means some of the architecture that I can design or that I can, that means design with respect to speed. Suppose in any specification, speed is my primary, that means aspects or this primary target where I will attack. That means I need one circuit where speed will get the highest priority, not the area and power is not that much, that means effective for designing that particular circuit. So, at that time how its architecture will be, or that means do I need to change the, that means the algorithm for that? If I fix the algorithm, then how the architecture will be, so that I will get the benefit in terms of speed, not the hardware or power. In some of the case, you may find that power and area, they are the major constant in your specification, not the speed. So, at that time how will I tackle those problems? So, that means for one particular adder architecture, if I just give one example, like we see that ripple carry adder, right. So, ripple carry adder, there what is the problem? So, the carry is, as the carry is rippling, so that means it take too much of time, that means the delay of that adder, that is very high. So, that means automatically the operating frequency for that particular design, that is lesser. So, that is why people have tried to overcome that problem by introducing the another, that means adder architecture, which is carry low carried adder. So, where that carry is generated and propagated simultaneously. So, that type of adder architecture is already there. Instead of that, there is several other that means adder architecture where I can get this kind of things, that means as I need that power as a major constant, at that time what type of architecture I will follow. If I need speed as a constant, so at that time what type of architecture I will follow. For the same function, I can implement, or I can, that means map to that particular function, or I can design different architecture for that particular function to be implemented on the circuit. Okay. So, we will try to see, or we will try to cover those things in this course. Apart from that, what I said, that those who are basically appearing for the interview in any digital design company like Samsung, Intel, Qualcomm, Freescale, all these companies. So, we will pick the problems or the, that means questions whichever has been asked during the interview. So, we will try to pick those questions and we will try to solve, or we will try to see that how the techniques, or what is the, that means targeting point, or what is the starting point to solve that problem. Okay. So, step by step we will see in this course. So, this will help to the students who are basically any students, whether he is in BTech, MTech or PhD, any students who is basically appearing for the their job interview, they will be also benefited by this course. Okay. This is 8 years, that means 8 weeks course. Okay. So, in this course, apart from this, there will be different, that means I will try to cover, there are different techniques for efficient implementation of the algorithm to the architecture mapping. Then there are different ways to implement adder architecture, different ways to implement multiplier architecture. Then by building these basic blocks, now how can I design one system? That means those who are doing research, they need to, they are not like only focusing on the basic components or the optimization at the basic components. They need to design one system, right? So that means starting from that means here we will see that bottom up approach. So first we will try to optimize the basic elements, then those basic elements how can I use in a system, that means how can I use in a systems perspective. So that's also we will try to see by considering some of the systems like this CODIG and FFT. These are the functions which also been used. Then this also been used in some of the higher levels, but we will not cover that. But the basic things like up to this FFT and this that means the signal processing functions, how they are being used, that will also be covered in this particular course. Okay. So this is the that means brief outline of this course. I think and another thing I just want to convey each of this that means participant in this course, that is whenever you feel, that means there will be a discussion forum, right? So whenever you feel that okay, you have some of the questions in your mind, you just put that thing in the discussion forum. Okay. So in actually that will be our job to try, that means that will be our or we will try our level best to solve those problems or how to start with those problems, and so that step by step you can solve that problem. Okay. So I think this will be much more helpful to all the students who will be registered in this course, and with that, thank you.